Here we have a problem on evaluating limits. Okay, so here limit extends to 0, e to the power 2x negative 1 over e to the x to the power negative 1. Okay, so first what I'm going to do is directly I'm going to substitute the given limit for x. That is, I'm going to plug in 0 for x into the function. So then what will I get? E to the power 2 times 0 negative 1 over e to the power 0 negative 1. Okay, so here 2 times 0 is 0. So then I'm getting e to the 0th power negative 1 over e to the 0th power negative 1. Okay, so anything raised to the power 0 equals to 1. So its value is just 1. I'm getting 1 negative 1 over 1 negative 1. So its result 0 over 0. So this is called indeterminate form. Okay, so whenever I get an indeterminate form as a result, when I evaluate a particular limit, so usually we people will be using L'Hopital's rule. But here I am not going to use L'Hopital's rule. Then what I'm going to do? So I'm going to simplify the function I have in this limit. Okay, first let me write the given limit as it is. It is limit extends to 0. So here we have e to the power 2x. So that means at the exponent of e, we have 2 and x are multiplied. So at the exponent, whenever two values are multiplied, one can be taken as a first exponent and other one can be taken as a second exponent. That is, so here I'm going to take x as the first exponent, and for the complete stuff, I'm taking this 2 as a second exponent. Even if I simplify this one using the power of a power rule, so that is I have to multiply the two exponents over here, then I'm getting the original stuff. So e to the power 2x can be written as e to the power x the whole square. So here instead of this e to the power 2x, I can write e to the power x the whole square negative 1 over e to the power x negative 1. And also I am taking square for this one. If I take square for this 1, so will it change the original value? No, because 1 square is always 1, still it is equal to the original value. So why should I take square for 1 over here? So because I just want to get the form a square negative b square. So what can I do if I get the form a square negative b square? So there is a basic algebraic identity, that is a square negative b square equals to a positive b times a negative b. So whenever I have the difference of two squares in the form a square negative b square, so it can be written as in the factor form. It can be written in the factor form, that is a positive b times a negative b. So comparing this and this, I get a equals to e to the x to the power and b is equal to 1. So for a positive b, what can I write? E to the x to the power positive 1, and for a negative b, I can write e to the x to the power negative 1. Okay, let me do it in the next step. That is limit extends to 0. So this stuff for a square negative b square can be written as a positive b. A positive b means for a we have e to the x to the power positive, for b we have 1, and again for a we have e to the x to the power negative, for b we have 1. Okay, so divided by e to the x to the power negative 1. So here this e to the x to the power negative 1, e to the x to the power negative 1 can be cancelled. So then I'm getting limit extends to 0, e to the x to the power positive 1. Okay, that's all the simplification I can do. Now what I can do is I can plug in the given limit, that is 0 for x over here. When I do so, I'm getting e to the 0th power positive 1. Already we know that anything raised to the power 0 equals to 1. So the value of this e to the 0th power is 1. So 1 positive 1 equals to 2. So the evaluation of the given limit is 2.